Greetings and welcome to a series of lectures on equations and inequalities in one variable. Lecture 2.5, Equations with Absolute Value. Let's recall what it means to have absolute value of a number. What that is the distance between the number and 0. The absolute value of x is x when x is greater than 0. The absolute value of x is the opposite of x when x is less than 0. Think of it like this. If x is 2, the absolute value of 2 is 2. If x is negative 2, then the absolute value of negative 2 is the opposite of negative 2, which in fact is 2. So let's solve for x. The absolute value of x is 5. Well, if the absolute value of x, if x is greater than 0, in other words, if x is 5, or when x is negative 5. So we have this cool rule. If the absolute value of a is b, and b is greater than 0, then a equals b, or a equals negative b. Might be a little bit easier to understand once we see it in action. So the absolute value of 2a minus 1 equals 7. Now using this rule, we'll treat 2a minus 1 as a. Now it's either going to equal b, meaning 7, or it's going to equal the opposite of 7. So let's break it up into two equations. Oh my gosh, lost my word. Okay, 2a minus 1 equals 7. Add 1 to both sides. We get 2a equals 8. Divide by 2 for both sides. We get a equals 4. Now let's try it when it's the opposite of 7. 2a minus 1 equals negative 7. Add 1 to both sides. 2a equals negative 6. Divide by 2 for both sides. A equals negative 3. But it's not good enough just to get a equals 4 and a equals negative 3. So let's verify. So when a is 4, I'm going to plug it into my original equation. The absolute value of 2 times 4 minus 1, does that equal 7? Well, 2 times 4 is 8. 8 minus 1 is 7. The absolute value of 7 is 7, so that works out. Let's try with negative 3. 2 times negative 3 is 6. Negative 6 minus 1 is negative 7. The absolute value of negative 7 is 7, and therefore 7 does equal 7. We'll try a couple of these. The absolute value of 2/3 x minus 3, all plus 5, equals 12. Now the first thing I'm going to do is try and simplify this problem as much as I can. Get the absolute value on one side, get everything else to the other. The absolute value of 2/3 x minus 3 plus 5 equals 12. I'm going to subtract the 5 from both sides, giving me the absolute value of 2/3 x plus 3 equals 7. Now I'm going to break it apart into two problems. Okay. The original one, 2x minus 3 equals 7, or 2x minus 3 equals the opposite of 7. Let's go back to the original problem. We're going to add 3 to both sides. 2/3 x equals 10. Multiplied by the reciprocal to both sides. Therefore, x equals 30 over 2, x equals 15. Now, when I run down the opposite of 7, I'm going to add 3, 2/3 x equals negative 4. Multiply the reciprocal of 2/3, which is 3/2, to both sides. X equals a negative 12 over 2, which will be x equals negative 6. So my solution set is negative 6 and 5. But let's run through and verify both of those. Okay. Push the screen up here. We'll concentrate on negative 6. I'm going to plug it into the original equation. Absolute value of 2/3 times negative 6 minus 3 plus 5 equals 12. Well, negative 2 times negative 6 is negative 12 over 3 minus 3 plus 5 equals 12. Negative 12 over 3 is 4, so negative 4 minus 3 plus 5 equals 12. Negative 4 minus 3 is negative 7. The absolute value of negative 7 is 7. 7 plus 5 does equal 12, therefore it is a good solution. Now let's try 15. 2 times 15 is 30. 30 over 3 is 10. 10 minus 3 is positive 7. The absolute value of positive 7 is 7. 7 plus 5 is 12. 12 equals 12. We're good there as well. All right, another example. The absolute value of 3a minus 6 equals negative 4. Well, you need to stop occasionally and say, is it even possible? Can an absolute value ever equal a negative number? Since the absolute value always yields a positive or a 0, therefore, this absolute value of 3a minus 6 can never be negative 4, can never be a negative number. Our solution set is the null set. There is no solution that makes this true. There is no value of a I can put in here to make that come out true. So it's okay to have a null set as your answer. Another way of thinking about this is if I have the square root of the absolute value of a equals the absolute value of b, then that means a equals b, or a equals the opposite of b, very similar to what we've been working with. Now it holds true that negative a, the opposite of a, must equal b, but it's actually this, even though it looks different, it's actually the same thing as a equals the opposite of b. B equaling the opposite of a. Literally, I can multiply negative 1 to both sides. I get right back to a equals the opposite of b. So we only have to test the equal situation as well as the opposite situation. We don't have to change. We don't have to check the third option here. So let's work with this fact. The absolute value of 3a plus 2 equals the absolute value of 2a, or 2a plus 3. I'm going to break this up into two problems. One is the equal situation. The other is the opposite situation. In the equal situation, 3a plus 2 equals 2a plus 3. In the opposite situation, 3a plus 2 equals the opposite of the whole thing of 2a plus 3. I'll worry about the opposite one in just a moment. So let's concentrate on equal. 3a plus 2 equals 2a plus 3. I'm going to subtract 2 from both sides. Does not matter if you move your variables first or your constants first. You get 3a equals 2a plus 1. I'm going to subtract 2a from both sides, leaving me with a equals 1. Now, let's concentrate on the opposite. Because I have the opposite of the whole thing of 2a plus 3, I need to distribute this negative to both terms in the parentheses. So 3a plus 2 will equal negative 2a minus 3. Going to subtract 2 from the left, subtract 2 from the right. 3a equals negative 2 minus 5. Add 2a to both sides. I'm going to get 5a equals negative 5. Divide by 5, a equals negative 1. So my solution set is negative 1, 1. Let's work through one more problem. The absolute value of x minus 5 equals the absolute value of x minus 7. Now again, we're going to break this up into equals and opposite. Okay. Equal is just going to pop out exactly how it is, just remove the absolute value markers. X minus 5 equals x minus 7. The opposite, you're going to choose one side for it to be the opposite of. I like to do the right-hand side as opposite. So negative 5, or x minus 5 equals the opposite of x minus 7. Now let's just work with the equals for now. I'm going to subtract x from both sides, and I'm going to end up with negative 5 equals negative 7. Now when can that ever happen? When can negative 5 ever equal negative 7? Well, in this case, for the equals option, there is no solution. Okay? Let's just keep that in mind. There's no solution. It's okay, but it's no solution. Now let's work with the opposite. Again, with the opposite, we want to distribute that negative. We're going to get x minus 5 equals negative x plus 7. Add x to both sides. I get 2x minus 5 equals 7. Add 5 to both sides. I get 2x equals 12. Divide by 2 on each side. X equals 6. So we did get a solution, but there is actually one solution, not two. The solution set is 6. That's it for this lecture. Until next time, be seeing you.